Okay. Well, then let's keep playing with the IO simulator for a little while and see what all we can do. Let's grab the from decimal command. And what we're going to do is take input and represent the number in memory as an appropriate number. Let me show you what I mean. This section over here, this input section, input 5, represents what you can call a thumb wheel. Okay, it's where a user, it's old, you don't do it this way anymore, but in the past, people would use thumb wheels that automatically converted the number you're putting in to a binary number. Okay, but nowadays, we don't really use that. We have other ways of inputting. But anyway, what we're going to do is use this as a thumb wheel where it's binary coded decimal. So the thumb wheel actually enters a binary coded decimal number into memory. Now that's not really the number we want. Let me show you what I mean. What I'm going to do is get rid of this 2 decimal command, and I'm going to get rid of that rung, and I'm going to take the number directly from I5, okay, and let me think, is this what I'm going to do?
How do you get rid of the rung?
I'm sorry?
How do you get rid of the rung?
Highlight the number in front of the rung and hit delete. Let's just play with it. I'm going to put the 06 directly in as the destination. Okay. Now, if I'm thinking right, this will actually work and look okay. I think the number that I put in here is going to appear over here. So, not quite what I was going for, but we'll get it. Download and run. Yeah, there we go. Good. Okay. So if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, life is good. Okay. As soon as I go to 9, still okay, but then if I increment over here to 1, 0, then A is displayed over here. What on earth is going on? How come it doesn't display 1, 0? Let me show you why. What I've done is I have taken the input data that's coming in here, and this command transforms it into an actual binary number. Okay, and then it puts that binary number out here. Because think about it. If we wanted to represent 10 in binary, how would you do it? What places would you turn on? Would you turn on the ones place? No, 10 is not an odd number. So you would not turn on the ones place. Would you turn on the twos place? Well, it turns out you would. Okay, would you turn on the fours place? No. Would you turn on the eights place? Yes, you would turn on the eights place because 8 plus 2 is 10. Make sense? So in straightforward binary, there's 10. Okay. But notice that what's happening here, this mechanism here is automatically converting my input to binary coded decimal, because instead of putting in 1010 in the low nibble, what it does is it puts in a 1 here and all zeros there, which is the way to do binary coded decimal, right? Because what we do is we devote a whole nibble to each of the decimal digits. Make sense? So what it's doing makes sense, because instead of interpreting this as the 16th place, the 1, 2, 4, 8, 16th place, it's not the 16th place. This is the ones place for this digit, and then the 2s, 4s, and 8s place. Make sense? So it's 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8, when we're talking about binary coded decimal. It's no longer 1, 2, 4, 8, 16, 32, 64. See what I'm saying? So, if I take this number, which is not really a binary number, it's a binary coded decimal number, and I try to display it, what's happening is this command converts the binary coded decimal number into an actual binary number. It converts it into this. And since I'm telling it to take that result and just put it directly out on the output, it does it, 0, 1, 0, 1. Which it just so happens is A, which is actually 10. Okay? So it actually works. But you have to understand that this is not displaying in base 10, it's displaying in base 16. Okay? Have I thoroughly confused you yet? Okay. What questions do you have? Don't know what what to ask.
Yeah.
Okay. All right, then let's do this differently. Let me show you one more command that will make this make a little more sense. This will give us the result that you probably expected. I'm going to show you the move command. Okay? Go one over the move or logical. We put that on here instead of this. Now I'm going to use the same addresses. I'm going to put input 5, the whole word of input 5, I'm going to put out on output 6. Okay? Download, run. Now it does exactly what you expect. It simply copies the bits just as they are over to the outputs. It simply takes the inputs and move or copies them to the outputs. It's unfortunate this name move because it doesn't take away from something. All it does is copy. You copy whatever addresses you want. Right now I'm choosing to copy input addresses to output addresses. But you don't have to do that. You can copy a memory address to output. You could copy the inputs to a memory address. Okay? So all I'm doing is copying the whole word on input 5 to the whole word on output 6. Make sense? And then what's displayed here is exactly what you would expect. The only caveat is that really 1,511 is not 10001001001010100 in binary. Okay? So to get used to this, if I keep talking and explaining, it's not going to work. When you start doing it, then you start understanding. So what I want all of you to do is to take this binary number and calculate its value in decimal, base 10, what you're used to. Okay? Try that and see what you get. Do you think you'll get 1,511? You won't. Okay? So try it. If this is the ones place, the 2s, 4s, 8s, 16, 32, and so on, figure out what the value of this number is. Okay? You may want to use Excel to make your life easier. Oh, I ran it. No, you're using some decimal. I use the same. If you go over to move logical, then you can move. I use the root command. When the window comes up like that, you don't have the full icons on your sheet, minimize it. So Windows 7 versus this whole program. The command that I enter, first one to go to simulations, IO simulator. There's a simulator over there, you can open it over. You probably won't know. Scroll over there, drop the move logical. Hit that heavy logical. So we're going to have, and you grab that and drop it. Drop it 1, 2, like that. And what I did is I just address the inputs to the source and this O colon again. You may want, if you want me to show you some more of it after class, I can, or if you want to get more sheet or do that, whatever you need.
I'll probably say class for one day.
Okay. Okay.
I appreciate it.
Any questions? Okay. Well, copy down this in binary. Okay, so this is the lowest significant bit. So start on your right hand side. Do 1. That's all. Is this one on? 0, 0.
this, you know how you have this, this is the ones that change the things. You might want to convert it, you might want to put a lot of this kind of. One thing I do is I turn the paper so late,
Yeah.
whatever it is.
Okay.
You get it?
Yeah.
Everyone got an answer? Anyone need help? How many people are done? Yeah, here it is. I'll give you all a few more minutes, because it looks like all the questions are not there.
Yeah. Yeah. Okay.
One, this, one, five, one. So, that's the same piece. What this actual number is here. This. Yeah, this is easy, and the world should this number be, and, find it over
What's that?
Did it make sense now?
Yeah. Yeah.
So now, how many people are done with the conversion? Okay. What numbers have we got? Got off some numbers, what have we got?
53.
Anybody else? Yep. Okay, how many people do we have to second that? 2, 3, most of them. So 5393 is probably correct. Okay, are you ready for all of you to really hate me? Ready? I'm gonna show you something. Now, even if you're not done, you may want to pay attention to this stuff, because this is really important. I'm gonna show you a really easy way to do all the conversions you ever want to do. You ready? Remember I had you bring up a calculator a few minutes ago? There's a reason for that. Windows Calculator has a really nice feature. Most people don't seem to know about it. Not only is there View Scientific, it's also View Programmer. Hit Programmer. Go to Binary. Are you ready? Now I'm going to type in this number in binary. I'm going to start at the most significant bit. The most significant bit is the bit that turns on the largest amount. Okay? So I'm going to start from the very end, which is 0. 0, 0, 0. Why doesn't it do anything? Because remember, we neglect leaving 0. Okay? 0, 0. Now I'm going to start at bit 12 right here. Okay? So it's a 1. Bit 11 is a 0. Bit 10 is a 1. Bit 9 is a 0. Bit 8 is a 1. Bit 7, 6, and 5 are zeros. Bit 4 is a 1. Bit 3 is a 0. 2 is a 0. 1 is a 0. And 0 is a 1. See what I just did? All I did is I typed 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. See what I did? That's what I have entered over here in the calculator. Now, ready for the magic? I don't know how much time it took you guys to calculate 5,393, but I can do it that quickly. Okay? All you do is you hit the decimal button and calculator does it for you. Now, if I asked you to give it to me in hexadecimal, then all you would do is just hit the hexadecimal button. And there you go. So all that conversion we did earlier, I want you to understand the base system and how it works. But I want you to be able to do this quickly. Okay, so you have to be a little careful with this. Decimal, I'm 40 years old. In hex, I am 28. In octal, I'm 50. In binary, I'm 101000. Okay. Yes.
Confused about how it reads the 1 hexadecimal. Is that
What-
the
what's that?
one in the I-5 column?
Yes, I5.
Is that the 1248, 1248, 1248? Is that how it reads it?
Right, that's the way it reads it, because, and it depends. If you've got the from decimal command, then it will read it as 1248, 1248, and so on. But I'm not using that command, I'm using the move command.
Okay.
So what it does is it simply copies this data over here. Now, you might be confused and say, well, how did that work then? How did it give me the right number that I entered? It works because this is already doing a conversion. It's already converting the number to binary code decimal. It's converting it from base 10 to binary code decimal, not to the proper number. Because 1511 in proper binary would look like this. Code decimal. 1151 in proper binary looks like that. And the least significant bits here should be on. There's 1, 2, 3, 4, 5, 6, 7 bits that should be on. But that's not what we observed. So that thumb wheel is already performing the conversion to binary code decimal, not to binary.
Okay.
See what I'm saying?
Yeah.
So that's why it works, because then this display is a binary code decimal display, so we simply copy it. No big deal. Okay. But when I use the from decimal command, what it did is it took this binary code decimal and changed it into true binary. And then when I displayed that binary, then it showed me hexadecimal, because the display is actually capable of hexadecimal. And binary converts directly to hexadecimal. Does it make sense now what happened a few moments ago?
Yeah.
All right. Now that I've worked your brain with counting in different bases, you can go home and tell your age in hexadecimal or in octal or whatever you want, really confuse people, right? Okay. All right, now that's interesting, and using binary code decimal and changing bases is important. It'll become second nature to you, basically. It's really not that difficult, especially once you realize you can use a calculator to do it. It's really easy then. But let's go to the door simulator, and let's start programming an actual system. I don't know about you guys. I know all of you have programmed before. Why don't we go around the room and kind of introduce what programming languages we program in. I'll start. I was in high school. I guess I was a real geek because I thought it was fun during the summer to learn assembly language and program in assembly. So I programmed in 6502 assembly on my Commodore 128 back in the day when I was a kid. And then I learned to program in C when I went to college, and of course BASIC, but BASIC, I don't know what BASIC really means. Okay.